Hello, fellow code whisperers and cosmic explorers. Welcome to PaperLedge, where we unravel the mysteries of cutting-edge research and translate them into something even your grandma could understand. Today, we're strapping on our spacesuits and diving headfirst into a fascinating paper about code translation, making computers speak each other's languages, like a digital Rosetta Stone. Now, code translation might sound like something only a silicon wizard would care about, but stick with me. Imagine you're trying to read an ancient scroll, but all you have is a phrasebook from a completely different civilization. Frustrating, right? That's what it's like for computers trying to understand code written in different languages. And that's where this paper, EffiReasonTrans, RL, Optimized Reasoning for Code Translation, comes in. The authors, Yanlin Wang, Ronji Oh, and a whole team of brilliant minds, tackle a crucial problem: how to make code translation faster and more accurate at the same time. It's like trying to build a warp drive that also gets great gas mileage. So, what's their secret sauce? Well, let's step into our memory palace, a sprawling digital library where each room holds a key insight from this paper. First, we enter the data synthesis chamber. This is where the authors built a super reliable training dataset. They started with existing code snippets and then used a powerful language model, DEEPS, to generate intermediate reasoning steps and the translated code. Think of it as teaching a student why they're translating something, not just what to translate. But here's the kicker: they didn't just blindly accept the model's output. No, sir, they put each translation through rigorous automated syntax and functionality checks. It's like having a digital editor and a code reviewer rolled into one. Next, we stroll into the supervised fine-tuning hall. Now that they had this pristine dataset, they used it to fine-tune another language model, DEEPS. Distill, QWENB. This is where they teach the model to recognize patterns in the code, reasoning, and translations. It's like giving our student a crash course in comparative linguistics, but for code. And finally, we arrive at the execution-based reinforcement learning arena. This is where things get really interesting. The authors used a technique called reinforcement learning to further refine the model's accuracy and, crucially, to optimize its inference latency. That's just a fancy way of saying, make it faster. Imagine training your student with a reward system. Get the translation right, and you get a gold star. Make it concise, and you get 2 gold stars. So, what did they find when they put EffiReasonTrans to the test? The results were impressive. The authors tested their framework on 6 different translation pairs, like Java to Python and to Java, and found that it consistently improved translation accuracy, while reducing the number of generated tokens and lowering inference latency. It's like they actually did build that warp drive with amazing gas mileage. But here's the thing: it's not just about speed and accuracy. By incorporating reasoning into the translation process, EffiReasonTrans also makes the translations more understandable. It's like adding footnotes to our ancient scroll, explaining the context and meaning behind each phrase. Now, you might be wondering if this is just a fancy academic exercise. Well, the authors also showed that EffiReasonTrans can be integrated into agent-based frameworks, which are used in real-world applications like automated code repair. It's like giving our student the tools they need to not just translate, but also to fix any errors they find along the way. So, what's the takeaway from all this? EffiReasonTrans is a significant step forward in code translation, offering a way to balance accuracy and efficiency by incorporating reasoning into the process. It's a reminder that even in the world of computers, understanding why something works is just as important as how it works. And that, my friends, is why this paper is a true gem. It not only advances the field of code translation but also offers a glimpse into the future of human-computer collaboration. Now, if you'll excuse me, I'm off to build my own memory palace to store all this newfound knowledge. Until next time, keep exploring, keep questioning, and keep those code translators humming. This is Ernis, signing off from PaperLedge.